Alright, so this is a video about special right triangles, and these are just kind of a shortcut to the Pythagorean theorem or trig, and it helps a lot. So we're going to kind of review what you should have done in geometry. So the two kinds of special right triangles are 45, 45, 90 and 30, 60, 90. For 45, 45, 90, it's an isosceles triangle, which means two of the sides will be the same. And also, I didn't write the other angle in here, but this is 90 and there's 180 total. So it's the complement. So the two 45s. And same here, 60 plus 30 is 90. So those don't have to all be written. I just kind of wanted to show that. All right, so the ratio of the sides in 45, 45, 90 are 1, 1, and the square root of 2. Sometimes I say 1, 1, 1 root 2. That rhythm just helps me somehow know what to do when it's kind of a straightforward case. When you're talking about a 30, 60, 90, the ratio of the sides is 1, 2, square root 3. And you know where to place them because if you remember from geometry, the smallest side is across from the smallest angle. So since 30 degrees is the smallest angle, the 1 would go across. The medium side is across from the medium angle, and the square root of 3 is less than 2. And the hypotenuse is always the longest. So these are the ratios we're going to be working with, and these are called reference triangles. So let's just do a couple quick examples just to make sure you get the idea, and then that's it. So the first problem is kind of a straightforward one that I just want to show you how the process works, but you can do this one in a quicker way than what I'm showing you. All right, so if we're going to use special right triangles to figure this one out, it's going to be the 45, 45, 90. So the way that you do it, or one of the many ways you can do it, is to just make little fractions out of the sides you're given and the reference triangle sides. Now for this one, this is a little bit more straightforward. Since it's isosceles, we know it's 13, 13, and this will be 13 root 2. But I want to show you why in the long way, so just kind of watch. You're going to take, let's say where your x is, x over 1 equals 13 over 1. Now if these numbers were more complicated, you would definitely cross multiply. So I'm going to go through those steps, but in this case you don't really have to. So 13 equals x. All right, and likewise we're going to do that same process but for y. So we have y over root 2, and we want to use this side because it has actual numbers on it. And we're going to cross multiply. And so it's exactly what we expected. This, again, is the most simplistic case you'll see. Let's do another. Obviously, these triangles aren't always oriented the same or drawn to scale, as evidenced by this one. All right, and again, this is kind of a straightforward case of a 30, 60, 90 that you could do in your head once you get really comfortable. But I just want to illustrate the process that one of the many processes you could use for this, so that's what we're going to do. So the angle or side across from the 30-degree angle is always over 1. It's the smallest side. The hypotenuse, always over 2. And the one across from what would be the 60-degree angle, the square root of 3. All right, so now we have our ratio set up. We can solve. X over root 3 is equal to 34 over 2. We're going to cross multiply. 34 root 3 equals 2x. And divide by 2. So 17 root 3 equals x. Same process for y. Y over 1 equals 34 over 2. Now again, we could just simplify 34 over 2 to 17, since y is over 1. Y will be 17. But if you want to see the whole process with cross multiplying, I'll do it. So y is 17. Okay. Let's look at another example. And I should probably give you an angle. Okay, so 60 degrees, we're going to fill in our sides from our reference triangle and make little ratios. Across from 30 is 1, hypotenuse is 2, across from 60 is the square root of 3. Now again, you could simplify this first and work with it that way, but I'm just going to show this way. The long way works always, so it's worth showing. Since x is over 1, you could just simplify that, but I'm, again, going to be redundant and show the whole process. And divide by the square root of 3. So 4 root 7 equals x. For y, we have y over 2 equals 4 root 21 over the square root of 3. Cross multiply. 8 root 21 equals y root 3, and divide. And you can see that these ratios stay very consistent as we go. Let's do one slightly more complicated one, and one where we have to rationalize the denominator. So let's do the rationalize the denominator one first. All right, so this is a 45, 45, 90 triangle, and the ratios are 1, 1, and the square root of 2. So to solve this for x, we're going to have x over 1 equals 28 over root 2. If we go through the whole process, we'll have 28 equals x root 2 and divide everything by root 2. So 28 over the square root of 2 is x. Now, as you know from our radicals unit, you cannot leave with a radical in the denominator. So we're going to rationalize by multiplying the numerator and denominator by the square root of 2. So we have 28 root 2 over 2. Because remember, the square root of 2 times the square root of 2 is the square root of 4, which is 2. Then we can divide. So 14 root 2 equals x. Now we could go through that identical process again for y, but in this case it's isosceles. I'm just going to kind of write my thoughts on here. It's isosceles, so x has to be equal to y. So y is also 14 root 2. Okay, but you could set up the ratio again if you wanted to. So that's with rationalizing. Let's do one more example. Just a little kind of more complicated one, and then you'll be on your merry way. All right, so this is kind of a compound image, and we're going to look at it in a couple different ways. So first, the first part of a problem like this is you have to figure out where to start. And the way you figure out where to start is you kind of look through the problem and see where you have enough information. So if I look at this triangle here, I can see that I have only one piece of information and two missing sides. I don't have any information on that side, so I don't have enough to work with that triangle. On this triangle here, I have two pieces of information and one missing. So that's great. I can find that missing side pretty easily. So we're going to start with this triangle. So let's find z. So it's a 45, 45, 90, which means we can put our little ratios on. Over 1, this would be something over 1, and over the square root of 2. So we're going to have z over 1 equals 10 root 6 over the square root of 2. Now, I am not going to cross multiply this time because I want to show you what you would do if you don't. Z over 1 is the same as just Z. And so if I simply simplify this side, I will be at the end. So Z is 10 root 3. All right. So instead of writing Z in the picture, I could have 10 root 3 there. And just because I know this part is a side of both triangles and would give me enough information to move forward with this triangle, I know this is a 45, 45, 90. So this also needs to be 10 root 3. So now we're going to be looking at the 30, 60, 90 triangle and putting our denominators. So across from the 30-degree angle is always over 1. Across from the 60-degree angle is over the square root of 3, and the hypotenuse over 2. So we can solve those last two little guys. We have x over 2 equals 10 root 3 over 1. Cross multiply leaves me with 20 root 3 equals x. And for y over the square root of 3 equals 10 root 3 over 1, and cross multiply. 10 root 3 equals y. So 10 times 3, 30 equals y. So now we have all three answers. So you can see you're going to have to kind of look through the problems and look for the missing information before you move forward to fill it in. All right, bye.